Okay, so hi everybody. My name is Martin Norgaard, and I'm a researcher at the Neurobiology Research Unit. And today I will just give you a short introduction about the brain imaging data structure for PET data. And I assume that most of you know PET data since you're here, but I'm just quickly going to go through this in sometimes very complex setup where you measure using PET scans. So it all goes back to that you have to generate the tracer that you want to use, and that goes back to the cyclotron. You produce a radio tracer, and then you inject the radio tracer into the blood. It goes into the brain, and from here it has a radioactive decay, and that's basically what you're measuring with your PET scanner. Then as another complex level of a PET scan, you often also measure blood levels or the radioactivity in the blood over time. And then finally the plasma. So what you see down here is the activity in plasma as a function of time. Then because you only get the function from the PET scan, then often you also acquire an MRI scan to get the features of a different region. You can register them, and then you can extract what we refer to as time activity curves for given regions, where you have the activity over time in a given region. And then finally, you can create these parametric images or volumes of interest, where you get the distribution of the receptor density in a specific location in the brain. Now, of course, there's also some drawbacks with PET imaging. And the first one is that PET studies, they are very expensive to perform. And often we have low sample sizes when we're doing PET studies. And I just want to give you an example from some of my own research, which has been for mostly DASP data, which targets the serotonin transporter. So the tracer was developed back in 2000. And since then, a big amount of studies have been performed. And actually, if you sum up over all these 105 published papers, you have about 2,700 subjects that have been acquired. And as you can see, it varies very much from, you have ADHD data, you have MDD data, but if you sum up the healthy controls, you have about 1,800 healthy controls that you can use. And the point that I want to make here is that you divide the total number of subjects with the number of studies here. You have about 20 to 30 subjects per study. And this includes both healthy and disease groups. Now, if you want to do data sharing and to increase the sample sizes, the thing is that even though you have the same type of data, it's often stored or acquired differently. And here I just want to give you an example from some data that we have here at NRU in Denmark, and some data that I've been so lucky to get hold on from Stony Brook and also previous Columbia. And thereby thank you to Christine De Lorenzo and Ramin Parsi for sharing this. But here, one case could be that in Copenhagen, we have an HRT scanner, and at Columbia, they have an HR Plus scanner. For both these PET data, the output is in V format, so an ECAT format from Siemens. But when it comes to the metadata or the blood data, it's very different how this has been stored. And let me just give you an example here. So this is an XLL file. It has the injected dose or the activity. Here it's in megabecquerel, but if you look at the data over here, the injected dose is instead this. It's much lower. And why is this? It's because it's in millicurie instead of megabecquerel. You also have the information of the parent fraction, the timing of the metabolites, the free fraction, when the plasma was acquired, and also the total activity in plasma over time. And you have the same information over here. The thing is just that this data has been stored differently. And at this point, I hope that the benefits of sharing and reusing data are hopefully obvious. But in order to move forward, we need a common specification to have the data in the same format. And what is this good for? Well, it improves data and interoperability and reusability. It also improves the scientific quality and the reproducibility. It also facilitates the shared tools and pipeline development when you want to process your data. And finally, it reduces stress since you don't have to come up with everything yourself. And this has been mentioned and discussed in the PET Society many times before. It goes back to the NRM in Boston in 2016, London 18, and should also have been a part of the Montreal conference this year. It was also part of BrainPet last year in Japan. And it's just important for me to say that PET-BIDS is designed by the community. It's a community effort, and it's an effort to facilitate sharing and analysis of PET data. That's the ultimate goal. Now, there's also been some important efforts since the conference in Boston 2016, and that includes these two papers. The first one here was published last year, specifying guidelines for the content and format of PET brain data in publications and archives, a consensus paper, which was mostly led by Gitte Knudsen and Bob Innes, and was really a game changer, I think, because it really took all the stakeholders in the PET field, or at least a big part of them, and they tried to come up with some guidelines, what should be in both publications and in a data archive if you want to share your data. Then there's also this paper. They specify something similar for the pharmaceuticals, and that's also a part of the PET experiment. So it's also important that some of the different parts of the experiments are aligned across expertise groups. Now, in order for us to be able to standardize the data, which is the goal of PET-BIDS, the real goal is to go from something that looks like this to something structured that looks like this. That's the first thing. But the second thing is that we need to make sure that we're also capturing the right information. So this includes some info about the experiment, something about the radiochemistry, timing information, reconstruction, and blood. And that basically comes from the guidelines that was published last year. Now, when we have the information that needs to go into the standard, there are some other things that we need to make sure are okay before we can do this. And that has something to do with how we structure our data and also in what file formats. And how the data is structured in the PET-BIDS for now, for PET imaging data, is that you have to specify a subjects folder. And that can have a participant label. And I'm just going to go through some of the examples here just to show you why it's important, especially when you have very different setups of the experiments. So first of all, if you have more subjects, you need to make sure that you can distinguish between that. So that could, for example, be subject 01. The second one here is that you have to define a session. And the session could be that, for example, it's a baseline scan. You could also have an intervention scan. But this is really the way to distinguish between these two. So they will have the same structure in the folder, but they will also have different name depending on whether it's a baseline or an intervention. Then with fMRI and PET combined being more and more popular, you could also have different tasks. So this could be a visual task, it could be resting state. When it comes to the acquisition of the PET data, it can be acquired using, for example, where it's attenuation corrected and it's a dynamic scan. It can have a reconstruction flag here. It could be OSM or it could be filter back projection. You can define that. And then if you have multiple runs within the same session, so this could be an FDG scan where you have like one scan and then you do another FDG scan right after, then you would specify this as run 1 and run 2. Now, it's not always that you're doing all this. So if you're not having different like types of data inside a subjects folder, you don't need to specify it. So if, for example, I just have the acquisition das AC dyn, it just means that I don't have to specify this. This will go into the metadata, which I will come back to in just a second. So to sum up, what I want to say with this slide is that this gives you a way to structure your data depending on the complexity of your experiment. It should take care of all, or at least most of types of different experiments for PET here, where you will have, again, the PET data. It will be stored in a nifty format, and you will have the PET data or the metadata associated with the PET data as a JSON file. And I'll come back to that in just a second. Before I can show you the final or the pretty close to finished PET-BIDS standard, I also have to just touch a little bit upon timing during the experiment. Because in PET experiments, it's very important to keep the timing straight. And to do that, one needs to define a common time scale where all the other components of the PET experiment has been defined too. And often a time zero will be defined either to injection of the tracer or at scan start. And then we need to adjust all the other components according to this time zero. And for a PET experiment, often what you would do is that you would draw and measure the radioactivity. That could be just a little bit before the injection of the tracer. You also specify when the tracer was injected. Then at the same time point here, you start the scan and you have the reconstruction here into different time frames where you have defined a frame start and a frame duration. And that basically includes the PET data. Now, if you also want to include blood data or measure blood data, then you also have to specify that. And if you have continuous blood samples, it's common to start that before you inject the tracer. And that's also high frequency. So if you start that here, you need to measure that again over time. And then it's not uncommon, if you have that, you also have discrete blood samples, which you measure more sparsely than the continuous, but over time. But it's very important that you keep all these measurement points exactly defined in accordance to each other, and that will be defined according to a joint time zero. Now, with this, I'm ready to show you how the PET BIDS standard looks like. And as I said, there will be a JSON format specifying here the subject 01 and its session 01. It contains all the necessary information related to the PET experiment. So it tells you something about the PET scanner, the unit of what you measured, something about the tracer, molecular weight, injected radioactivity, specific radioactivity, molar activity measurement time, all the different components that are a part of the guidelines paper as specified. Then you also have information about the PET scan, so frame time start, and you also have information about the reconstruction. And for more specific, you can go to this web page where everything is specified. Now, when it comes to blood, we also need to define that. And as I said, it's not uncommon that if you have continuous recordings of blood, you also have discrete measurements. And the way that that is defined in the PET BIDS standard is that all the information related to blood will go into a tabular separated file, a TSV file, where you have defined all columns here, where the first one will be time, then the second one here, that could be the plasma radioactivity, third one, whole blood radioactivity. And then for each TSV file here, for either discrete or continuous, there will be also a JSON file specifying each column in the TSV file. So here first you have the time, and you have a description of each column, and you will specify what units the columns are in. And to sum this up, we have a set of different example data sets where you can try to get familiar with the structure of the PET BIDS standard. We have one here. This is a PIC data set, which makes it easier to share, of the serotonin 2A measured with SIMD36. There are arterial measurements available. Please go in and have a look. And we also have some different types of PET data sets that you can use to get familiar with. And then finally, I just again want to specify that PET BIDS is a community effort. This really is unique because everyone is a part of it. What we also need to do next is that we need to develop local converters to get the data into BIDS format. Again, because at each different site, you will have different ways of structuring your data. So we need to develop local converters that can get it into BIDS format, and then we will be able to share the data. And then finally, a plan is also to help in the future to facilitate data sharing across PET centers. And that includes databases where you can store the data, but also facilitate or help at least with some of the legal aspects that are a part of this. And with that, I just want to say thank you for your attention, and please go in and have a look at the standard right here. And if you have any questions, I'd be happy to answer them.